Okay, today let's talk a little bit about stoichiometry. Stoichiometry is often an intimidating topic for students in chemistry, but if you just think about it as predictive math, just predicting how much you should make, it kind of makes it a little easier to understand. So with stoichiometry, what we're doing, we're looking at reactions, we're looking at processes, and predicting the amount of a substance that's needed or the amount of a substance that would be created. So here we have a reaction of octane, often found in gasoline and fuels, combusting to produce the carbon dioxide in the water, and we want to figure out how much carbon dioxide is emitted. Okay? So with stoichiometry, I like to use this stoichiometry island diagram that has a lot of the roadmap, so to say, of how to solve stoichiometry problems in chemistry. The most important thing is to have a balanced equation, so we got to make sure that our chemical reaction, that the equation written is balanced. And then we start at one of these particular islands and move across through a series of calculations to predict how many particles, how much volume or mass, how many grams will be produced of a particular product or needed of a particular reactant. So let's start working on this problem here. Okay, we have 582 grams of octane. And we are going to determine how many grams of carbon dioxide is needed. So let's set up a conversion factor and do some dimensional analysis. Okay, the first thing we want to do is change our grams to moles. Okay, and our conversion factor is going to be 1 mole of the octane is equal to its molar mass. So 1 mole of C8H18, and the molar mass, remember to get the molar mass, we take the elements in the compound and their molar mass from the periodic table, add all these up, so we took 8 of the carbon masses, 18 of the hydrogen masses, added all that up to get our molar mass, the weight of 1 mole. Okay. See, and by that conversion factor, we are canceling out the grams and changing it to moles. Now, we'll continue on and we'll go from moles to moles, from the known octane to the unknown carbon dioxide. We use the coefficients from the balanced equation to get a mole ratio. So we have 16 moles of carbon dioxide come from 2 moles of octane. Okay, so that is going to cancel out the moles of octane. Okay, so what we've done on our roadmap, we've gone from grams to moles of octane, and now we've converted it over to moles of carbon dioxide. And we're going to go one more step, and we're going to go to grams of carbon dioxide using the mole to molar mass conversion factor. Okay, so here we are, 1 mole of carbon dioxide and its molar mass. Again, we're just retrieving the mass numbers from the periodic table. And we now have everything converted. Notice all of our units have canceled out, and all we're left with is grams of carbon dioxide. And we solve this conversion. Okay. Now, so let's take our calculator, and we will go 582 times 16 times 44.01. Okay, that's our numerator. And then we'll divide it by the 114.3 times 2. So we'll go divided by 114.3 times 2. And we get, it looks like 1,793 if we were going to round. So 1793 grams. But we have 3 sig figs in our first quantity, so let's round this to 1,790. Okay, so 1,790 grams of CO2. Okay, so stoichiometry is just a series of conversions or dimensional analysis to predict the amount of a product that will be produced or the amount of reactant needed to produce that product. Okay,